Hello students, so welcome to the Study Nurture channel, and from today we are going to start our new series of lectures of mechanical vibrations. It is a subject in mechanical engineering BTech for the 7th semester students. So as we know that vibrations, we often experience examples of vibration in our daily lives. Like we have seen the simple pendulum, guitar, earthquakes cause the vibrations, and when we travel on the road on a rough road, the vehicle experience vibrations. So let's start with the basic introduction. What is vibration? Vibration is a mechanical phenomena where oscillations occur about an equilibrium point. So you can take an example of spring mass system. In this spring mass system, the vibrations take place about the equilibrium point. That means about a mean position. This mass moves up and down. So it is a mechanical phenomena where oscillations occur about an equilibrium point. Similarly, you can take an example of simple pendulum as well. So with the discovery of musical instruments like drums, vibration became a point of interest for the scientists. So as the musical instruments are going to be discovered, so the vibration become the point of interest. So there are two main things that are necessary for a system to vibrate, that means mass and elasticity. So all bodies having mass and elasticity are capable of vibration. So mass is inherent to the body, but you have to know what is elasticity. The ability of an object or material to resume its normal shape after being stretched or compressed. So when we stretch something or when we compress something, for example a spring, when we stretch it, it has a tendency to resume to its normal shape. This property is called elasticity, and due to this property the system vibrates. So what is the basic concept of vibration? This thing we will cover by a simple example of a simple pendulum. So as you can see, at position A, the pendulum is at the mean position, and when we take it to point B, that means at extreme right corner, there is only potential energy stored in the bob. And when we leave it at point B, this pendulum starts to move towards A. And when it starts to move, its potential energy is going to be converted into kinetic energy, and at the center position there will be only kinetic energy, because whole of the potential energy at point B has been converted into kinetic energy. So due to kinetic energy at point A, this pendulum starts to move towards the left side, that is up to extreme point C. At point C, there will be only potential energy, and on the way, the kinetic energy is converted into potential energy. So in this way, the cycle continues and the system vibrates. So there is a exchange of energy from potential energy to kinetic energy. So what are the reasons of vibrations? The main reason is unbalanced centrifugal force in the system. This happens because of non-uniform material distribution in a rotating machine element. For example, you have a rotating rotor here, and due to improper material distribution, its center of gravity is not at the center of the disk. It is shifted towards the left side with the distance e, which is known as eccentricity. So due to this eccentricity, when this rotor rotates at high speed, there will be excessive vibrations in the system due to unbalanced centrifugal forces. Second reason is elastic nature of the system. As we have discussed earlier, for a system to vibrate, there should be elasticity inside the system. So the third reason is external excitation applied on the system. If you want to remove the vibration of a system, the first thing you want to do is to remove the external excitation. Fourth reason is the winds, the natural winds, which cause the vibration of certain systems like electric lines, telephone lines, etc. So what is the importance of vibration study in engineering? So due to faulty design and poor manufacturing, there is unbalance in the engine which cause unpleasant stresses in the system. So if you don't remove the vibrations or the vibrations occur in your system, there will be unpleasant and unnecessary stresses on your system, which will cause the rapid wear of machine parts. It will reduce the life of the machine parts. There will be loosening of the parts from the machine. Because of improper material distribution, wheels of the locomotive can leave the track and cause a heavy accident or heavy loss. Many building structures fall because of vibration. Because of heavy vibrations, proper reading of the instruments cannot be taken. Excessive vibration is dangerous to human beings. When a human being is exposed to heavy vibration for a longer period of time, it is also not good for the physical of human body. Vibration can be used for useful purposes also, like vibrations are useful in vibration testing equipments, vibratory conveyors, hoppers, sieves, compactors, musical instruments, and it is useful for propagation of sound. How you will remove the undesirable vibrations? The first of all, remove the external excitation if possible. Use the shock absorbers, you can use the dynamic absorbers, and you can use the vibration isolators as well. These shock absorber, dynamic absorbers, isolators we will cover in the upcoming lectures. So now let's discuss what are the different types of vibrations. The first type is forced and free vibrations. So when you disturb a system, for example, you have a simple pendulum, and when you disturb it by initial input, this system starts to vibrate. And when it is vibrating, you do not disturb it. Means you left it as it is by applying the first initial force. When the system vibrates on its own without any external influence, it is called free vibration. On the contrary, forced vibration. A forced vibration is something which is under the influence of external force all the time. For example, electric bell, lathe machine, drill machine, any kind of machine tool, when the switch is on, the machine is working and the vibrations happen. These are all forced vibrations. So free vibration occurs when a mechanical system is set in motion with an initial input and allowed to vibrate freely. Examples are when a child is swinging on the pendulum, you pull it back and you leave it, and the pendulum is swinging by its own. Or you can see a turning tuning fork, like for the ENT doctors, they have a tuning fork and they hit it and let it ring. What is forced vibration? When a periodic disturbing force keeps the body in vibration throughout its entire period of motion, such vibration is said to be forced vibration. Or you can say the vibration which is under the influence of external force throughout the motion. So here in this diagram you can see we have mass M, we have spring stiffness K, we have damping coefficient C, and we have applied the external F, and it is periodic force. F naught sine omega t means it is a periodic force, means it is a vibrating force. Second type is longitudinal, transverse and torsional vibrations. This we will understand by a diagram. So here in this diagram you can see in longitudinal vibration, for example, we have massless spindle and a mass attached to it at point B. B is the mean position, and this mass vibrates up and down from position A to position C. So these vibrations take place along the axis of the spindle. It means it is longitudinal vibration. So you can say when the vibration take place along the axis of the spindle, these are called longitudinal vibrations, like spring mass system. So for the transverse vibration, you can see here you have the same massless spindle and a mass attached at point B neutral position, and the system vibrates from point A to point C. So these are called transverse vibration because the vibration take place almost perpendicular to the axis of the spindle. So this is the axis of the spindle, and the vibration take place almost perpendicular to the axis of the spindle. So in the third diagram, for the torsional vibration, you have a rotor or rotating disc with attached to the wire or spindle, a very thin wire, massless. And this body, the rotor, twists and untwists about the spindle axis. These are called torsional vibrations. Next type is damped and undamped vibrations. So it's very simple. When you have a damper in a system, then the vibrations under the influence of this damper or friction are called damped vibrations. So you have a system here in which you have mass, you have spring K, and you have damper with damping coefficient C. These are called damped vibrations because the system has damper in it. And if you remove this damper, means you have only mass and spring in the system and there is no damper, it means that it is undamped vibrations. Next type is deterministic and random vibrations. In deterministic vibrations, the amplitude or magnitude of the external excitation is known. So the amount of external excitation is known in magnitude for the deterministic vibrations. On the contrary, in random vibrations, the magnitude of the external force is not known to us. So these are the diagrams for deterministic and random vibrations. You can see for the deterministic, the amount of force is fixed and you know the amount of force acting on the system. These are called deterministic vibrations. On the contrary, for the random vibrations, the amount of force is not known to you. Next type is transient vibrations. As you know that for a ideal system, when there is no damping, or you can say for an undamped ideal system, the vibrations will never stop because there is no damping. But in the real systems, you can always see that the system comes to rest after some time. So for the real systems, even if there is no damping, but the system vibrations will die out after some time. So these vibrations in the real system without damper are called transient vibrations. So you can see even without the damper, the system comes to rest after some time. The next type is linear and non-linear vibrations. As the name suggests, when the parts of the vibratory system like spring, mass and damper behave in a linear manner, then the vibrations are called vibrations. On the other hand, when the parts of the vibratory system like spring, mass and damper, if any of the part behave in a non-linear manner, then the system is called non-linear vibrations. So if in a vibratory system mass, spring and damper behave in a linear manner, the vibrations caused are known as linear and these are governed by linear differential equations. On the other hand, if any of the component of the vibratory system behave non-linearly, the vibrations are called non-linear vibrations. So the blue lines indicates that it is a linear vibration and the red and maroon line indicates that it is a non-linear vibrations. So that's it for the today and keep watching Study Nurture channel and we will go through more lectures for the mechanical vibration subject. So thank you students.